All right, good morning, guys. So today we're going to be continuing our unit on conics, right? We know conics are circles, parabolas, ellipses, and hyperbolas. And what we're going to do is we're going to kind of continue that kind of just thought, things that are circular or curved, and we're going to be taking a look at what's called polar graphs. And so if we have a polar graph, then that means we must have a polar coordinate. So we're going to be taking a look mostly at polar coordinates today. All right, but I want to show you can do something really cool in your calculator, so I would encourage you right now to pause the video and go grab your calculator. All right, so once you have your calculator, what we're going to do is we're actually going to change the mode. So go ahead and click mode. All right, and instead of having your calculator in function mode, we're actually going to go over to polar mode. Okay, and the other thing that we want to do is we want to have our calculator in radian mode. Okay, you can technically do it in either way, I believe, but we're going to have it in radian mode. So I'm going to go ahead and quit this screen, and what we're going to do is we are going to insert an equation. So I'm going to do y equals, and you can see that this looks different already. Normally we would have something like y1 and y2, and now we have r1 and r2. When we deal with things that are polar, we're dealing with a radius and an angle, so theta. So now instead of y equals, we have r equals. All right, so I'm going to go ahead and plug in an equation, and I would encourage you guys to do the same. So I'm going to plug in 3 times cosine of 2 theta. And what's cool is that because you're in polar mode, if you hit the X button, which is right next to your alpha, if you hit the X button, you're actually going to get a theta symbol because of the mode that you're in. So I'm going to go ahead and close my parentheses. And then the next thing I want to do is I want to just check my window. All right. So my theta, because I'm in radians, you want to make sure that you're thinking about, well, what does a full circle look like in radians? And that's 2 pi. If you wanted to, you could even go as far as 4 pi. Things can get pretty repetitive at that point, so let's just go ahead and do 2 pi if you don't already have that. All right, our minimum is going to be the angle 0, so we're going to start with 0 degrees, and we're going to go all the way to 2 pi. And you guys know already that that changes to decimals. All right. Don't worry about your theta step, although you do want it to be a small value. So you know what, let's go ahead and take care of that. Let's do 0.1. You want it to be a small value because basically our graph is going to plug in theta in increments of 0.1. So that's a lot of angles. And we're going to get a very exact, well, pretty exact look at what this graph looks like. Now my x, min, and max, what we're going to do is we're going to do 0. And let's go ahead and do something like, actually let's try -6 and +6. Let's try that. All right. And the scale, you can keep that 1. So now let's go ahead and graph, and this is going to be really cool. All right. So we can see that we have something that's very curved. Now, I must have plugged in something wrong because we don't see the whole window. Oh, you know what? I'm sorry. The y, min, and max. We can change that as well. Let's go ahead and do just -6 and +6. Let's just mirror what we had for the x's. Now let's go ahead and graph so you can see the whole thing. All right. So we have this curved graph, which is a polar graph. All right, so we're going to be taking a look at all of the points that make up these kinds of graphs. So these are polar coordinates. All right, so we're going to take a look at a few examples.